In this video, we're going to go over trigonometric functions of real numbers. So we'll be using our unit circle to be able to find the values of sine, cosine, and tangent, which you should be pretty familiar with from geometry, as well as cosecant, secant, and cotangent, which I will explain in more detail. So if we go ahead and look at our unit circle, we already know that if you go some length around your unit circle, some value of t, or you can refer to it as some angle. So if you have, for example, oops, there we go. You could have some angle theta. We could find the terminal point at that either t or theta value, and identify from that terminal point its x and y coordinates. Now your trig functions come from those coordinates. Sine of that angle would be the y coordinate, cosine of that angle would be the x coordinate, and then tangent is y over x. With the stipulation that x is not allowed to be 0 because you can't divide by 0 or else you end up with an undefined answer. Now these other three trig functions are what are called your reciprocal identities, and so they are essentially the quote flipped versions of your sine, cosine, and tangent trig identities. Cosecant, which is how you pronounce it, would be 1 over y, so it's the reciprocal or flipped version of sine. With the stipulation that y cannot be 0. Secant is the reciprocal of cosine, and cotangent is the flipped version of tangent. Oops. And so given an angle and your unit circle, you should be able to find the trig function of each of the trig functions of that angle using the coordinate points of the terminal point there. So now what we're going to do is we are going to find the 6 trigonometric functions of t equals pi over 3. So I'm going to first find sine, cosine, and tangent of pi over 3, and then we'll work with the reciprocals. So sine of pi over 3, cosine of pi over 3, and then tangent of pi over 3. And you're going to need your unit circle, so it's helpful to have that as well. So first and foremost, we go to pi over 3 on our unit circle and identify the terminal point there, because we're going to rely on that x value and that y value to find at least these three answers first. So sine of pi over 3 is the y coordinate of your terminal point. So automatically I go to my terminal point, I look at the y value. So sine of pi over 3 is the square root of 3 over 2. Cosine is the x coordinate, so cosine of pi over 3 would be 1/2. And then tangent is when you would normally do, you do y over x, so square root of 3 over 2 over 1/2, and then to simplify, you would have to flip and multiply instead. The nice part about that is that your 2's would cancel out, and so your answer for this one would just be the square root of 3. Now, we don't want to go ahead and have to do those calculations every single time, so we've actually gone ahead and put our tangents on our unit circle, but just to show you how you get it, you do your y value over your x value, and then you simplify. You will have to be able to do this later without using your unit circle, or without using necessarily these exact points on your unit circle. Okay, so then those are your sine, cosine, and tangent answers. And so now we're going to go ahead and we're going to move on to our cosecant, secant, and cotangent answers. And to get these, the first way that you should start off is you have to find the reciprocal of your sine, cosine, and tangent, or if you want to write yourself a note, you're going to flip these previous answers. That's what it means to find the reciprocal. So if I flip 2, or square root of 3 over 2, I end up with 2 over the square root of 3. If I flip 1/2, it gets me 2 over 1. If I flip, let's see, square root of 3 is technically secretly over 1, so when I flip it, I'll get 1 over the square root of 3. And then we have to perform one more action because Math is finicky. So a lot of times in mathematics, we don't like our answers with irrational numbers in the denominator. So these have square root of 3, and square root of 3 are not nice numbers. So anytime you have a square root in the denominator that you can't actually evaluate. So if this was square root of 4, it would be fine, but because square root of 4 is 2, but we can't find the square root of 3 nicely. So anytime you have a square root in the denominator that you can't simplify, we have to use a method called rationalization, or you're going to rationalize, which means that you get rid of the square root in the denominator by multiplying by it. And you'll see what I mean here. So when we want to actually get rid of the square root in the denominator, I'm going to multiply the top and the bottom by that square root. I don't have to worry about it here because I don't have a square root in the denominator, but I do have to worry about it here. So you just take whatever that square root of the denominator was and you multiply the top and the bottom by it. And then when we multiply, we just go straight across. So 2 times the square root of 3 is just 2 square roots of 3 because you can't combine those in any way. One of them is outside of the square root, one of them is inside, so you just end up with 2 square root of 3. On the bottom, you have square root of 3 times the square root of 3. So if I was going to do that, square root of 3 times the square root of 3, oops. You can actually combine those into the square root of 9 because they're both underneath a square root, so you can combine them underneath one square root. But we all know that the square root of 9 is actually 3. So then your final answer, when we went straight across the top and straight across the bottom, would be 2 square roots of 3 over 3. And so this is officially your answer that has a rational denominator, and so it is fully correct. 2 over 1, we didn't have to really do much simplification of. 2 over 1 is just 2. And then cotangent of pi over 3, we do the same thing, multiply straight across the top, so you get 1 square root of 3 on top, and then square root of 3 times square root of 3 is just 3 in the bottom. So you have found all 6 trig functions. These are your final answers for t equals pi over 3. We're going to go ahead and do another example here. So we're going to find 6 trig functions of t equals 7 pi over 6. Oops. How about we actually find them? So sine of 7 pi over 6. Cosine of 7 pi over 6. And tangent. I always start with those 3 because those determine your reciprocal identities. So sine of 7 pi over 6, I go to 7 pi over 6 on my unit circle, find my y value, which is negative 1/2. Cosine of 7 pi over 6 is my x coordinate, so negative square root of 3 over 2. And then tangent is already listed there, or you could find it, square root of 3 over 3. Lovely. To find your reciprocal identities then, we just need to write pi's correctly, and then find the reciprocal or flipped versions of our first 3 trig functions. All right, so when I flip negative 1/2, I get negative 2 over 1, which is just negative 2. One side note, a lot of students sometimes have trouble with the idea that this negative can move around wherever it wants, but we want to identify that even if you write negative 1 divided by 4, or 1 divided by negative 4, or negative the fraction 1/4, these all mean exactly the same thing. As long as you have a negative somewhere, then they all result in the same piece. So I don't mind if your negative stayed out front, moved up with a 2, moved down with a 1. As long as your final answer is still a negative 2, you're good to go. Secant would be if I flipped this guy, so negative 2 over the square root of 3, and then we'll have to rationalize him. And then tangent, when I flip that one, is 3 over the square root of 3, and we'll have to rationalize there as well. So when I do that, you want to multiply by what you're trying to get rid of in the denominator. I end up with negative 2 square roots of 3 over 3, right? Square root of 3 times square root of 3 is square root of 9, which is just 3. And then on the cotangent, 3 square roots of 3 over 3. And then you can actually take one extra step here. 3 divided by 3, they cancel out. So your final answer for cotangent is just square root of 3. All right. In this next example, I did want to do one specifically with either one of your four axes. So because these points can be a little bit tricky just because they involve zero. So when I want to find the six trig functions of t equals pi, I'm going to find the same way that I find it normally, sine of pi, cosine of pi, and tangent of pi. So I go to pi on my unit circle, which is right here. My sine of pi would be the y value, 0. My cosine of pi would be -1. And then how I get my tangent is I do y over x, so 0 divided by -1, which is just 0. Now, one thing to look out for is when you're finding the reciprocals of things that involve 0. So when I'm finding the reciprocal of 0, technically this is 0 over 1. And so when I flip it, I get 1 over 0. And remember I talked about how you're not allowed to divide by 0? That is what we call an undefined answer. So if you're asked to find cosecant of pi, your answer is technically undefined. -1, when I find the reciprocal of that, I'll still get -1, so that's fine. And then same thing with tangent. Technically, to find tangent, we did 0 over -1, right? Y over x. So when I flip that, you still end up with a 0 in the denominator, so it's still undefined. All right, let's look at these last examples really quickly. So sometimes you could be asked to find just the sine, cosine, or tangent, or cosecant, secant, cotangent of angles, and then that's it. You don't have to find all six, which is okay. So if I go to 2 pi over 3 on my unit circle, cosine is -1/2, and then you're actually done with that problem. Now, tangent of -pi over 3 is a little tricky just because we don't have a -pi over 3 on our unit circle. This is actually too small, so we have to find a coterminal angle first, but that's not anything new. We've already learned about coterminal angles. Same thing with the sine problem. 19 pi over 4 is too big, so we'll have to find a coterminal angle first. And so to do that, I'm going to take my -pi over 3 and add a full circle to it because it's too small. Make sure you get those common denominators before you actually add them together. So then -pi over 3 plus 6 pi over 3 equals 5 pi over 3. Oops, I'm going to write it up here. So then really in this problem, I'm not finding tangent of -pi over 3, I'm finding tangent of 5 pi over 3, which according to my unit circle is -square root of 3. So we're done with that problem. And then for one that's too big, we want to subtract full circles from it because 19 pi over 4 isn't on our unit circle right now. It's too big, so we'll subtract full circles from it. 19 pi over 4 minus 2 pi. Again, make sure you get those common denominators first. So then it turns into 19 pi over 4 minus 8 pi over 4, which is 11 pi over 4, which is still too big. So we'll do it one more time. So you can subtract one more circle from it. Oops, not over 3. All right, so then now instead of being asked to find sine of 19 pi over 4, we're being asked to find sine of 3 pi over 4, which is actually on our unit circle. Sine is the y coordinate, square root of 2 over 2. There we go. All right, let me know if you have any questions. Other than that, you can go ahead and practice.